Welcome to online learning prepared by Teacher Edward James from Patumsuk sa 5 Anuban Taksin Bankay International School. This video recording is for educational purposes only. My name is Teacher Edward and I am your speaker for today. Before we are going to dive into our lesson today, let's have a quick review on what we have studied last time. Last time, we studied the factors affecting friction force and how to lower or increase the friction force. The first one is the weights and forces pressing on the surface. So if the force pressing on the surface is high, the friction force is high as well, hence becoming the heavy box very difficult to push. For a light object, the force pressing on the surface is low, so the friction force is low. Therefore, it's easier to push the light box compared to the heavy box. And also, I would like to highlight the friction force in both pictures. The heavy box have a longer arrow. It means that the friction force is stronger, and on the light box, the arrow is comparatively smaller than the heavy box. It means that the friction force is much weaker when it is shorter. Number 2, types of contact forces. For smooth surface, the friction force is very low, so you can push it easily on a smooth surface. Second example here is that when you push an object on a rough surface, then the friction is very high, therefore it's very difficult to push, or you need to exert more force so that you can push the object. Another lesson that we study is the action and reaction force, like the one you can see in the picture. When you have this skateboard and then you're going to use it, when you kick or when you push the ground, that is your action, then it will propel to the reaction, and that is the ground pushing on you. Then your skateboard will move forward. Another example is that when the man kicked the wall, okay, and there are wheels on the chair that he is sitting, so there will be a reaction force and the man will move backwards. Alright, so let's proceed. For this part, we are going to play an online science lab. It's entitled Forces and Motion. Let's begin. Oh, I didn't see you there. I guess you are the new crew member. First, we need to talk about a force. We refer to a push or a pull an object receives because of the interaction with one another. So that is force. Okay, so you can see that there are 1, 2, 3, 4, 5, 6 robots. If I turn off the gravity, they will start to float. Okay, and when I turn this on, they will fall down. So that is also a force. So it's not it's a push and a pull, and there's a gravity also. All right, now let's go to the next part. Which one of these two robots is pulling? The one on the left, the one on the right, or none? I'll give you 5 seconds to think of your answer. Correct. The correct answer is right. Good job. Let's go to the next question. Which one is pulling? Very good. The one on the left. Good job. What about this? Which one is pulling? The correct answer is the one on the right. Good job. Alright, let's try this game. We need our net force to go on this tube right here so that we can catch the box. Remember that these four robots on the left are already locked, so we cannot delete, we cannot do anything with them. So we have 3 spaces here. What should we do? Okay, so we will exert one robot, one pulling robot. We will add another one, and we'll add another one. Okay, so let's click enter. Good job! I hope you enjoy the game. Again, if you want to play this game on your vacant time, you can just search PHET and then you can search forces and motion. Alright, our lesson for today is all about forces diagram. Today you will be able to identify different forces acting on an object. You will also draw, and you will also try to explain the force diagram that you made, and you will be able to share your thoughts about the importance of force in our daily life. Are you ready? Let's begin in our vocabulary words. Number 1, I want you to repeat each word after I will read them. Diagram. Diagram. Number 2, normal force. Normal force. Number 3, friction force. Friction force. Number 4, force of gravity. Force of gravity. Number 5, stationary. Stationary. You can pause for a while and then you can copy all these 5 words because you will be needing them in our vocabulary exercise later on. Diagram. A diagram is a simplified drawing showing the appearance, structure, or workings of something. A schematic representation. A diagram of the living room. So we can use the word diagram in a sentence like that. Normal force. Normal force is what we call an everyday force that is felt when a surface pushes against an object that is placed on that surface, like this box on a table. So the table will push the box upward. We call it a normal force. And there is also the weight force or the gravity. But this box will not move because the normal force and the weight force are equal, or what we call balance. Okay? Friction force is the force of resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. So the man here is pulling the object, and the friction force is the opposite force acting on an object. Force of gravity. On Earth, this is what we call the downward force. Okay, everything that goes up or above will eventually fall down because of the force of gravity. Stationary means not moving or not intended to be moved. Example, a car collided with a stationary vehicle. Alright, at this point in time, I hope you are ready for our vocabulary exercise. We have here a crossword puzzle and I want you to complete it. Please pause the video right now and look at the down and across. These are the clue on how you are going to complete the puzzle. Of course, all the words that are used here are part of our vocabulary words earlier. Good luck! these are all the correct answers. I hope you get all the words correctly. Now let's go to the diagram of forces. Here we can see a simple picture, a trolley that is being pulled by a boy, and the girl is also helping in pushing. So we can see here that there are 5 forces acting on this object. We have the force of gravity, we have the friction force, we have the normal force, and the 2 forces going to the right. One force for the girl and another for the boy. Okay? On this diagram, there are 4 forces: the gravity, the friction, the reaction force or the normal force, and the pushing force. Okay, so all these forces will act on this wooden block which is 25 kilogram. Okay, another example is this free body diagrams. So we have here the normal force F sub n. We also have F sub t, or the force of tension, because the man here is using a chain or a rope to carry this box. We have a force of friction, and we have also the weight force or the gravity force. Okay, so there are 4 forces acting on this object. Okay, so at this point in time, we are going to watch a short video about our lesson for today. So let's try to watch this short clip. I want you to ready your notebook so that you can copy as well. Are you ready? Okay.
And then you can try the rest. Let this horizontal line be the top of the table and the box is placed here. The free body diagram shows all the forces acting on it. First, there is a force of gravity acting on it. It will be downwards. And then there is a normal force acting upwards. As the forces are equal and opposite, the box does not move at all. It continues to remain at rest. And also notice that the size of the arrows is the same. The forces are balanced and the net force is 0.
Okay, so for this example, there is a skydiver that is descending with a constant velocity, and there's also an egg that is free falling from a nest in a tree. So how many forces acting on these 2 objects right here? I will be giving you 10 seconds to think of your answer. Alright, on number 4, there are 2 forces acting on it. The first one is the force of gravity that is pulling the man or the skydiver going down to the Earth's surface. And there's also the air resistance, the normal force that is acting on this person that is free falling. But the stronger force is the force of gravity. That's why the man will be constantly descending. Okay, the same thing with an egg. There are 2 forces acting on a falling egg. The force of gravity, which is stronger, and the other one is the air resistance, okay, or the normal force, which is not that as strong as the force of gravity. So I hope you learned something about this short video clip. Let's try practicing some of these questions right here. In which of the following diagrams do the directions of all the vectors shown correctly represent a free body diagram of the forces acting on Earth due to sun's gravity? I'll give you 3 seconds to think of your answer. The correct answer is letter B. Very good. Question number 2. Look at the wheel of a car going to the left, and point P is the one you can see that is color yellow. So which of the following is the correct free body diagram showing the forces acting on point P? What is your answer? Correct answer is letter C. Good job. Okay, so here a box is pulled along a surface by an applied force of 32 Newton, and there is the horizontal net force of the box is 24 Newton. What is the magnitude of force F? You can see here 16 Newton up, 16 Newton down, and 32 Newton to the right. So how much is force F if the net force is 24 Newton? The correct answer is F is equal to 24 is equal to 32 minus F. So the correct answer is 8 Newton because 32 minus 24 is equal to 8. So the force F is 8 Newton. Okay, so I hope you learned something for today. And now is the time for you to answer the Google form. Okay, and thank you for coming. Always be safe and see you again next time. Goodbye.